Hello, my name is McLoughlin. I work for a company called EventStore with Alexi, and I wanted to come and talk to you guys about two of our flagship products, which is EventStoreDB and, more importantly, EventStore Cloud. Now, to give a bit of a background on the company, it was formed in around about 2012 by a gentleman called Greg Young. And if any of you are familiar with event sourcing, you'll probably heard the name, as he was one of the main thought leaders when this kind of movement started. And the database has been growing. Our product has been growing since. I'm not going to do that. Has been growing since, and we've been picking up more and more customers. And as a team, we're up to about 40 developers now. Now, EventStoreDB at its core is a database for storing events, which makes it very good for building event source applications. Now, there's a number of reasons why it is good, but one of the ones which I want to call out is this concept of fine-grained streams. And that is to say that in EventStoreDB, you can have as many streams as you want. And they're all ordered. So in this case here, you can see we have a number of invoice streams, which are individual invoices, an invoice category above that, and then an all above that. Each of these with their own individual position. Now, the reason this is important for event source applications is because it allows you to have a stream per aggregate. Now, there are a lot of other reasons why EventStoreDB is good, and just to go through some of them here. Firstly, there are guaranteed writes. Now, this might seem obvious, but when a database writes some data to disk, or tells you it has, but it has actually written. That's not always the case. It can sometimes be in the buffer. With EventStoreDB, when we say it's on disk, it is actually on disk. We have high availability. EventStoreDB can run as a cluster of 3 or more nodes. So it should one of the nodes go down, then another one will pick up a weight. We have something called projections, which we'll talk a little bit about later, but this is a system within inside EventStoreDB that allows you to look for events and build up new streams off the back of those events. We have multiple client APIs. Up until recently, we only had a supported .NET client, but in recent releases, we moved from a TCP protocol to gRPC. That's allowed us to create clients in multiple different languages. We've now got Java, Node, Go, Haskell, Rust, and .NET. And we're planning on adding Python, Ruby, PHP over the coming months. We have optimistic concurrency checks. This is another key requirement of an event sourcing database, is that we allow you to check to make sure that two people aren't trying to add events to the same stream at the same time. We have great performance because we are a database built specifically for storing events. That means we've been able to optimize for that purpose, whereas other general purpose databases have to make compromises for other use cases. We haven't had to. We have commercial support plans, so it is an open source product. You can go and get it, and you can go and use it as you see fit. But we do have commercial support plans should you go into production and want a little bit of a safety net there. It's an immutable data store. Once you've written an event, it cannot be modified, which gives it better guarantees as an audit log. And as I say, we've got multiple hosting options. So as well as the cloud, it can be run through Docker, it can be run on Windows, Ubuntu, multiple different options out there. So there's one other thing that I want to call out a little bit here as well, and this is regarding the benefits of using EventStore. Now, if you've been around event sourcing a while, you will have seen this diagram or similar before, and this is the idea that with a relational database, we throw a lot of data away when we do updates and deletes, whereas with an event store, you've got every single event that's been in your application since the beginning of time. And this is really powerful because it effectively becomes a transaction log for your application. And that means that it allows you to create and recreate, lots of different data models for very specific use cases in multiple different databases for in real time. And this is a real powerful part of building distributed applications. And it's one of the things that at EventStore we're looking to exploit and help you guys exploit. So As I said, we've got EventStoreDB, and as Alexi mentioned in the intro, my apologies, I'm not presenting. Let's try that. There we go. Sorry about that. As I mentioned, as Lex mentioned in the intro, we introduced EventStore Cloud about 18 months ago. And essentially, this is our way of providing EventStoreDB hosted on the three main cloud platforms, so GCP, Azure, and AWS. And it allows you to go in and create clusters and use them as you see fit, and we will take care of the maintenance of the clusters and the uptime, and also we make sure that they're run in the most performant manner possible. So rather than just talking about it, it probably makes sense to have a bit of a demo. So this is EventStore Cloud. To talk a little bit about the structure that sits within EventStore, you can have multiple organizations, and within any given organization, you can have multiple projects. This allows you to organize your clusters in any way you see fit. It might be that you have a project per service or a project per environment. We have everything you would expect to see from access control. So you can see here we've got a number of members. You can invite new members to the team, adding them to a group. And then we can use groups and policies to control the access to the various resources, preventing people from creating or deleting clusters by accident. We also have some basic settings where we can limit the invitations to a given domain. This basically stops you from accidentally inviting somebody outside the company, which could prove problematic. You see here, we've got identity sources grayed out. This is a feature that we're going to be adding in the future, which if you want to control your access via some tool like Duende or Auth0, then you'll be able to integrate with them and manage it all there. If we go into a project, we can see on the left-hand side, we've got clusters, backups, events, console, networks, pairings, jobs, integrations, and settings. Now, networks and pairings are probably the first things we want to talk about. So by default, we don't expose the clusters over the public internet. This is for security reasons. We don't want just anybody being able to access it. That means the first thing you need to do is create a network with an EventStore Cloud, and then peer that network with a network within your own infrastructure. So the two can talk to each other, and then you can create clusters as you see fit, and the two will be able to communicate. So to create a new network, it's as simple as giving it a name, picking where you wish to where you wish your network to be. So it can either be a AWS, Azure, or GCP. You can pick the region. It would be, in my case anyway, it'd be EU West 2 or any of the others. Give it a CIDR block that's large enough to accommodate the number of clusters you want to create, and then just create the network. Now, unfortunately, because I have no faith in demos, I've already got one created for me, just in case. So after you've created this network, it takes a while to provision, maybe a minute or so. You can then create the peering between the two. Now, each of the networks, each of the cloud providers works in a slightly different fashion. But because we're on AWS, we can pick the network which we wish to peer, and then we can add in some of the information from our AWS account. So that's the account ID, the VPC ID, and the CIDR block of the actual account. These can all be got from within your AWS console. Then once you've actually created that peering, you just have to go into the AWS side and basically accept that peering, which will be somewhere in here. You'll basically get a little pop-up saying, hey, I've got a new network I want to peer. You accept it and then update your route tables, and then the two can talk to each other. So that's a one-time only operation that you have to do. Once that's done, you have to, you don't have to do it again. And you can go ahead and you can go and create a cluster. So let's do that. So we will call this one test cluster. You get to pick the provider you wish to host it on. Again, in our case, it's AWS. Then there's a number of options to pick. The first one is the server version. This, at the moment, we've got 20.6, 20.10, and 21.6. For those that are familiar with EventStore previously, we just used a simple incrementing version. About a year and a half ago, we switched so that we would have the year and the month, and we're going to release 3 times a year. So there'll be a .2 release, a .6 release, and a .10 release. The idea behind this is it gives some assurance to our customers and our users when they can expect a new release. Also makes it a lot clearer as to how long a release will be supported for. We then got projections. As I mentioned earlier, this is an internal system within EventStoreDB that allows you to listen out for streams and create new, listen out for events and create new events and streams off the back of it. We have some default ones, which are system projections, and we also have the ability to create our own, which we'll do in a moment, so we'll turn it on. Then you can pick the size of a VM. We've got everything from an F1, which is 2 core, 2 gig, all the way up to an M128, which is 32 core and 128 gig. We kind of give some indication as to what sort of load you can expect to handle. We have this concept of a working set, which is effectively how many streams you are working with at a given time. So 100,000 streams all the way up to 62 million streams. So we'll pick an F1 for now. Topology, either a single node or a free node. We are looking at the possibility of adding a 5-node cluster, and also the possibility of adding additional nodes that we call read-only replicas, which are nodes that kind of sit off to the side of a cluster, and specifically you can scale them out specifically for reads. You can then pick how much disk space you want. In this case, we'll just leave it at 8 gigabytes because, as I'll show later on, you can scale that up and down as you see fit, and then you pick the network which you want to run it on. Little indication as to how much we'd expect it to cost a month. We've kind of tried to make it so that the entry machines are pretty cheap to get started with, and then you can just go ahead and create a cluster, and it'll set off and start provisioning. Whilst that's working, we'll talk about some of the other features. So we have backups. You can do a one-time backup where we provide you with these tags, so that if you want to suffix it with the date time that it was taken, you can do so. Or you can create a backup schedule that can run every 1 hour, day, week at a particular time. And we also have a pruning functionality so that we only keep the most recent backups around. We have the ability to resize the disk. So if you find that you're running low on disk space, it's easy enough to just increase the size. This is an online process, so we won't take down the cluster as we do it. And we will also be adding functionality later so that you'll be able to scale up and scale down the size of a VM. So should you find yourself underpowered, we'll be able to do that as well. Similarly with the EventStore version itself, when we release new versions of EventStore, we will notify you and we will put a big red button there saying upgrade, and then you can click the button and we will handle the upgrade process for you as well. We have the events console. This is a place you'll come to see if there's been any issues. So if for any reason there is high CPU usage or you're running low of memory, we'll send you a notification letting you know there's a problem. And if you want to be woken up at unreasonable times in the morning, we also have integrations with Slack, Opsgenie, and PagerDuty. So should we have an issue or notification, then you can push it out via one of these services too. Let's see if the cluster's almost there we go. So the cluster is now created. Now, to actually connect to the cluster, as I said, we don't expose a public IP address for the cluster. So you first need to be able to connect to your own infrastructure, and this can be done by a number of ways. You can either have a jump box of some kind within your network that you can add EP onto and then connect to our cluster, or you can use a product like Tailscale VPN to VPN to your network, and then you can connect to that as well. We've got good documentation that basically walks you through something like setting up Tailscale. It's a pretty easy process. It shouldn't take too long. And then once you've done that, hopefully you can come into the address bar, click on the UI, and then you'll be taken through to the cluster. This is the dashboard for EventStoreDB itself. Basic things like seeing the stream browsers. So this is a list of all the streams that have been created. And we'll take a couple of things, but we'll take a look at projections specifically. So as I said several times now, this is a way of being able to have a part of the application that sits there, part of EventStoreDB that sits there, listens out for events and generates new streams. We have some default ones, which we'll get set running now, which will produce new streams. So say, for example, we have this by event type stream. And what this will do is it will look out for any stream, any event that comes in and puts them in a stream by their event type. So if you have an event that's called, I don't know, as you'll see soon, patient admitted, this will generate a stream with all the patient admitted events in, which is actually pretty cool. And you can also create your own as well. So I've got a sample application, which I'll show in a second, but to explain what it is, I used to work for the NHS, and part of the application we built was about tracking a patient's journey through the hospital. And we call this an encounter. A patient could be admitted, it could be transferred between wards, and they eventually, hopefully, at the end of it, will get discharged. So we have this concept of a what's called a encounter aggregate, and that is we had an encounter aggregate per encounter per patient. And one of the things we wanted to do is actually, as well as seeing these all at the encounter level, we wanted to have a ward stream, which tracked every time somebody got admitted to a ward and every time they got discharged from a ward. And we could do this via projection. So rather than typing it all in, paste this code in and explain what it does. Name first. So here we're writing a little piece of JavaScript code that basically says, I want to listen to the all stream. So this is, I want to listen to every event that comes into this, into EventStoreDB. When I see the patient transferred event, I want to do two things. The first thing I want to do is I want to admit an event to a stream, which is called ward hyphen, and then the current ward that the user is in, the patient is in. I want to admit an event called patient discharge from ward. I want to have this information in it, which is just basically the patient ID, and away you go. The second one is exactly the same, but it's emitting an event into the ward that they will be transferring to. So what we'll see here is each time somebody leaves a ward, we add that event to the relevant wards stream, and each time they move into a new ward, we'll add that as well. We have to enable admit, which is a safety check, and then we can create the projection. What have I missed? Enable checkpoints, continuous. There we go. I've already created it twice. There we go. So next is actually putting some events into the cluster itself. So going back to the UI, we can see down here, we've got the gRPC connection string. We can copy this and simply take it into our application, which as I mentioned is generating some seed data. And it's just a case of copying that string in there and then running the application. And hopefully away we go. There you go. So you can see it's pushing a load of events into EventStoreDB. If we come back here to the stream browser, you can see all of the encounters that are getting created. And you can also see the wards, which has got people being admitted to and discharged from wards. One other good thing which you can do with this in EventStore is actually see, when you come into an event like this, is you can actually go and see which event caused this one to be created. So we can come in here and go, this. You can see here now we had a patient transferred event that came in, and that generated both a patient discharged from ward event and a patient admitted to ward event, which is pretty cool. It opens up a lot of flexibility, you know, as far as generating new streams, again, for specific use cases. One other thing to talk about as well when it comes to the console is it's not just the UI for creating and managing all these resources. We also have a Terraform provider. We also have a Pulumi provider, and we also have a command line tool as well called ESC. You can use this for querying projects you have. You can get it in JSON. And then you can also use it for creating the resource as well. So there is a command called manage EventStoreDB.clusters create. You can see you just have to provide all the same information that we actually provided via the UI. It just gives it a bit more of a flexible way of actually creating and managing these resources. Okay, so that's kind of the cloud in a nutshell. We've got plans going forwards. You know, we are by no means feature complete, nor do I ever think we will be, because we want to keep on improving this offering. Some of the things that are going to be coming in the future, we're going to be doing better workload estimates to give you a better indication as to what sort of VM size you should be picking. We're going to be doing monthly forecasting and invoicing to give you a better idea of actually how much money you're spending on this service, so that things don't get out of control. We are building migration tools that will help you move data onto the cloud. So a lot of people are already using EventStoreDB. We needed a way to get onto the cloud, and we're going to try and make that as easy as possible. I mentioned about vertical scaling. One small thing here is the ability to empty or reset databases. We're going to be very careful about this, but it will be useful too. Read replicas, which I mentioned earlier. Schedule scavenging. This is basically the only one of the only maintenance tasks you have to perform on ESDB, which is a scavenge. We're going to do a lot of work around the APM so that we can push out exactly how well the cluster is performing, improved access controls, and a lot more. We've got a lot of ideas on how we actually want to build this product and where we want to take it to the next stage. EventStoreDB itself, which I should mention as well, actually, it just comes to mind. This is a question that gets asked a lot. The cloud isn't running some bespoke database. It is EventStoreDB under the hood. So all the functionality that you get from the actual open source product is in the cloud as well. And this is going to be undergoing some big developments in the future as well. So there's a lot of things that people have been asking for, which we're now getting in a position to add, such as geo-replication, multi-tenancy, so that you can handle multiple tenants within the same database, better stream partitioning, a query language, so that there's more than just the ability to read forward and backward through a stream. You'll actually have the ability to go in and call out specific events. More dedicated node types to allow more flexibility in cluster types. Schema tooling, this will allow you to enforce particular event types at a database level as opposed to just within the application. And a couple of things that I'm really looking forward to, which is going to be a new CLI. So that you can, as well as being able to manage your cloud via the console, you'll also be able to manage your database via the console. We're also looking at putting together a proper management studio as well, which I think will be great. And as I mentioned with the thing that I called out at the start around being able to push data into multiple different locations, we're looking at improving the integrations with third parties. So you'll be able to, you know, easily push events into other databases or into message queues or into Twitter. I don't know, whatever. We're going to try and hook into all of those, and lots of ongoing performance improvements. You know, this is a product that's been around for a long time and has seen a lot of performance improvements, but we're continuously focusing on making it the fastest event database out there. That's pretty much it. Some links. If you're interested in the cloud, by all means, jump on our website. There's It's advertised everywhere, so I'm sure you'll find yourself to the right location.